Happy morning to one and all present here. I am Dr. T. Anupratibha, Associate Professor, Department of Information Technology from VSB Engineering College, Karur. So, in this session, we are going to see about artificial intelligence and machine learning topics. First, we will see about, I'll share my screen and then we will proceed. Fine. Yes. So now in this session, we are going to see about artificial intelligence and machine learning. So already I have introduced myself. And the contents are Introduction to Artificial Intelligence. Second one is Applications of Artificial Intelligence. And third one is Problem Solving Agents. So here, what do you mean by intelligence first? The capacity to learn and solve the problems. So what do you mean by what is artificial intelligence? It is to simulate the human intelligence by machines. Simulation is nothing but the imitation of human intelligence by machines. So here, through this artificial intelligence, we have the ability to solve the problems, to think rationally, and to act like humans. This is, we are making the machines to act like humans. So the central principles of AI include reasoning, knowledge, planning, learning, and communication. Perception and the ability to move and manipulate objects. It is a science and engineering of making intelligent machines, especially intelligent computer programs. So this artificial intelligence, in this artificial intelligence, it is the outermost layer in which the first subset of artificial intelligence is machine learning, and next subset of our machine learning is deep learning. The intersection of all these three, artificial intelligence, machine learning, and deep learning, is data science. So here we will see the definition of artificial intelligence. It is a term refers to the ability of computer systems to perform tasks that typically require human intelligence. AI, it uses a mathematical and logical operations to simulate human reasoning and can process new information quickly and accurately. Next, the history of artificial intelligence, the evolution. So from 1950, the time when it all started, and 1955, John McCarthy coined the term artificial intelligence. And in 1974, computers became faster and affordable. And in 1980, it was the era of artificial intelligence. And 2000, landmark of AI establishment achieved. So this is a small history of artificial intelligence. And next, we are going to see about the applications of artificial intelligence in various fields. First, we will see the application of artificial intelligence in the medicinal field. So it is mainly meant for drug development, medical imaging, diagnosis, disease diagnosis, and patient monitoring and robot-assisted surgery. Everything is happening nowadays with the help of this artificial intelligence. And even in the field of music, the AI plays a vital role. So the scientists, they are trying to make computer emulate the activities of skillful musician. So the composition, performance, sound processing are some of the major areas on research in music. And AI are focusing on checks, smart music, etc. So here, the applications of AI, the possible applications of artificial intelligence, it is first in the field of robotics and soft robotics, Internet of Things, image analytics, graph analytics, audio analytics, visualization, visual personal assistant, natural language processing, deep learning, simulation modeling, machine translation, social network analysis, machine learning, and in sample text analysis also. Next, we are going to see about the problem solving agents. So before entering into this problem solving agents, I would like to say about two types of searches. One is local search, next one is global search. Local search is heuristic and global search is meta heuristic, that is heuristic about heuristic. So here, through these agents, we are going to perform certain searching activities. So now we will see about the problem solving agents, solving problems by searching. The first one is reflex agent, which is very simple. So it is based on their actions, a direct mapping from states to actions, but cannot work well in environments which this mapping would be too large to store and would take too long to learn. Hence, we are moving towards the goal-based agent. So here, a kind of goal-based agent, it solves a problem by finding sequence of actions that lead to desirable states. To solve a problem, the first step is the goal formulation based on the current situation. So there may be, for example, if you want to perform a search, that is if you are in some airport in some source place, and if you want to reach some destination point, then automatically you need uh, the correct optimistic and efficient, in efficient way, in effective manner, when we will reach the destination point in the less time. So the path cost as well as the search time should be very less. So that is what is considered to be the good thing, good analysis. So the goal is formulated as a set of world states in which the goal is satisfied. So reaching from the initial state to the goal state. Actions, we need the actions because we are moving towards goal-based agent. So actions are the operators causing transition between the world states. So these actions should be abstract enough at a certain degree instead of very detailed move. Example, turn left versus turn left 30 degree, etc. Likewise. And problem formulation, the process of deciding what actions and states to consider. For example, if you want to drive from Amman to Zarqa, in between the states and actions defined, states are some places in Amman and Zarqa, and actions to turn left, turn right, go straight, accelerate, and brake, etc. The search is like, because there are many ways to achieve the same goal. There may be multiple alternate solutions for the to reach the same goal. So those ways are together expressed as a tree and multiple options of unknown value at a point. The agent can examine different possible sequences of actions and choose the best. So this process of looking for the best sequence is called searching. So the best sequence is then a list of actions called solution. And there are many search algorithms. It is defined as taking a problem and returning a solution. So once a solution is found, the agent follows the solution and carries out the list of actions. That is what the execution phase actually, how we are going to reach from the source point to the destination point. So the design of an agent to formulate, search, and execute. So this is a algorithm for simple problem solving agent. It's a function which for each and every perception, it receives it returns the action. So here problem solving agent is defined as P, which is going to return an action. The inputs are the agent, the action, perception. So the static thing is, yes, an action sequence. Initially, it will be empty. Nobody knows how to reach the destination from and to in a very small time. So initially, it will be empty state. Some description of current world state can be given as G. That is what where we are starting a goal initially. Goal and initially it will be null, and problem a formulation and state update state, we have to update the states. That is, for example, if you want to reach from India to Saudi Arabia, then there should be some, uh, I mean, the points to reach from which country we can move to the which place by place, we need the states. So that is what we have to update the states. And here the states, it means that the particular place from where we are, from one, it's a, like transition from one place to another place to reach the destination point. If yes is empty, then we have to formulate the goal. That is, we have to find the easiest path. So problem, we can formulate the problem by using the states and as well as the current world state G, which is that is what the goal. That is initially none. And yes, yes is assigned the search problem, and recommendation of states is given as the action. It is given to action, and finally it will return the actions. That is here. This is like it's a simple problem solving agent. The algorithm defines that how we are going to set your goal, because we are going to find the destination using the goal based agent. So here now we are going to start from one place to from the source place to the destination place, where this source place will be the initial one, and at the initial stage the path how we are going to reach the destination point will be null, and then it's like moving from one transition state to another transition state, and finally to reach the goal in the easiest path. That is shortest path algorithms will be used here. Even the breadth first search algorithm and depth first search algorithm, everything can be used here. And well-defined problems and solutions. So here the problem is defined by 5 components: initial state, actions, transition model or successor functions, goal test, and path cost. So well-defined problems and solutions. So we can define a problem by 4 components. The first one is the initial state. The agent starts in the set of possible actions, transition model or successor functions, and a path in the state space. So the initial state that the agent where they are going to start from. The set of possible actions, how many transition states or successor functions they are going to have. That is description of what each action does. For example, if you have 10 transition states, in each and every transition state, what you're going to do. Successor functions refers to any state reachable from given state by a single action. So initial state, actions, and transition model define the state space. The set of all states reachable from the initial state by any sequence of actions. So a path is the state space. So here any sequence of states connected by a sequence of actions. So the well-defined problems and solutions, the goal test, applied to the current state to test. So if the agent is in its goal, and sometimes there is an explicit set of possible goal states. Example, if the source point is in AMN, and sometimes the goal is described by the properties instead of stating explicitly the set of states. Example, chess. So the agent wins if it can capture the king of the opponent on the next move. That is what called as the checkmate. So no matter what the opponent does. In this well-defined problems and solutions, the next thing is component is the path cost function. Assigns a numeric cost to each path. So it is equivalent to performance measure denoted by G to distinguish the best path from others. Usually the path cost is the sum of the step cost of the individual actions. So each and every individual action combined together it helps us to reach the destination point. That is what our goal. So together a problem is defined by initial state, actions, successor function, and goal test, and finally pathcast function. The solution of a problem is then a path from the initial state to a state satisfying the goal test. Optimal solution, the solution with lowest path cost among all solutions. And the formulating the problems. Besides the four components for problem formulation, whereas anything else apart from that means the abstraction is the process to take out the irrelevant information, leave the most essential parts to the description of the states. So we can, the outliers can be removed. The conclusion is only the most important parts that are contributing to the search can be used. And the next thing is evaluation criteria. So the formulation of a problem as a search task, basic search strategies, important properties of search strategies, selection of search strategies for specific tasks. So already we have seen about goal formulation. So here like the agents whose task is to solve a particular problem. First one is goal formulation. What is a goal state? What are important characteristics of the goal state? How does the agent know that it has reached the goal? Are there several possible goal states? Are they equal or some more preferable states are there? And this is what regarding the goal formulation. And regarding problem formulation, what are all the possible states of the world relevant for solving the problem? So what information is accessible to the agent? How can the agent progress from the state to state? So this is like a map from where we have to reach from Amman to Zarqa. So the pathcast from 15 kilometer directly from Amman to Zarqa we can reach. So that is what is the desirable solution. From our example, we can formulate, we are in Amman and your formulation of the problem is cities, drive between cities. How many cities you are going to move from? I mean, you're going to locate. And then finally, you'll be reaching the Zarqa city. That is what the solution. That is, you have to reach the destination point with the path cost, with the lowest path cost. So this is some example I have given from the problem to go from Aslan to Amman. So this is like initial state operator from how we are moving from one city to another city. It's like transition. And even this is also one more example from Romania, currently in a raid. So flight leaves from Bucharest. So here this is to formulate the goal. You can also formulate the goal, formulate problem, and you can find the solution. And single state problem formulation. Excuse me. So it requires four items. Initial state, example at a rate, actions or successor functions, where S of x is equal to set of action, that is state pairs. So this is like the transition states from where to where you're going to move and how you're going to reach the destination point. So the goal test can be explicit. Example, x is equal to at Bucharest. Implicit, it is a checkmate of x. And podcast is additive. So example, sum of distances, number of actions executed, etc. So a solution is a sequence of action leading from the initial state to the goal state. Some example problems we will see for this thing. And that is toy problems and real world problems. Those intended to illustrate or exercise various problem solving methods like puzzles, chess, etc. Real world problem means tend to be more difficult and whose solutions people actually care about. Example, design, planning, etc. So this is a toy problem. That is there is a vacuum cleaner and some dirt areas are there. So number of states is 8 states. So we have to plan any one initial state, and number of actions will be either from left or from right. We have to clean or we have to suck the dirty things, and no and we have to remove the dust. So the goal is to clean up all dirt things. The goal states 7 and 8. It is actually there is no dust, and path cast is each step casts one. So this is like this is what the actual way of removing the dust. So this is like the map, how you're going to move from left to right, or you're going to suck the dirt, how you're going to move. Based upon the position of the account cleaner, we can make the move. So in the 8% problem, how we are going to arrange from 1 to 8 states. So the start state, you will have a shuffled state. In the goal state, you have to arrange the numbers. So the state description specifies the location of each of the 8 tiles and blank in one of the 9 squares. So initial state is the state space. Successor function, the blank moves left, right, up or down. And the goal test is to current state matches the goal configuration, and the path cost is each step costs 1. So the path cost is just the length of the path. So thank you, dear students, for your listening. And this artificial intelligence is like the outermost layer of machine learning and deep learning. And from in the upcoming sessions, we will see about heuristic search strategies and informed and uninformed search strategies. And thank you all.